chemistry chapter of class 12, chapter number 10, Haloalkenes and Haloarenes. So first of all, let us start our chapter. Now, what does student halo means? What does this halo means? Halo means student halogens. What does halo means? Halo means halogen. Now, what are halogens, student? Halogens are the elements which are present in the group 17 of the periodic table. Means the elements which are present in the group 17 of the periodic tables are called halogen. For example, like fluorine, chlorine, bromine, iodine and acetylene. So these are the elements which are present in our halogen family, which is come under the category of group 17. Understood, students? Now the halogens are represented, which generally represent the halogen with letter X. We represent the halogen with letter X. Whenever you will use halogens in haloalkanes and haloarenes, or wherever you will use in organic chemistry, you will use the letter X. So this is the way to represent the halogen. X can be anything, maybe fluorine, chlorine, bromine, iodine or acetylene. Okay, so keep this thing in your mind. And students, I am not considering the acetylene in haloalkanes and haloarenes. Why? Because acetylene is a radioactive element. It's really very rare to get the compound of acetylene. So that is why we will not consider the acetylene in haloalkanes and arenes. So I think I should rub it. Okay, so we will not consider it. Now second thing, student, now a general idea you want in a halogen. Now in halogen, the outermost electron present in there is 7 electrons are present in their outermost shell. Means in the elements which are belong to the halogen family, in this the 7 electrons are present in their outermost shell. What do you understand when 7 electrons are present in their outermost shell? Means they need one electron. They need one electron to complete their octet, to attain the noble gas configuration. Okay, and why I am saying the noble gas configuration? Because you know noble gas come in the category in the group number 18, and in group number 18 noble gas configuration, they are having in the outermost shell 8 electrons are there, means their orbit is complete, so they will not participate in the chemical reaction. And every element want to achieve the noble gas configuration. So same thing, if they will get the 7 electron, if they will gain 1 electron, then they will achieve the noble gas configuration. So that is why if you will say the halogen family members are having show the valency 1, they will show the valency 1. It means the halogen family members show the valency 1. They are having 7 electrons in the outermost shell. The members of the families are fluorine, chlorine, bromine, iodine, etc. So these are the members of the halogen. I think this much is enough for you for studying the haloalkenes and haloarenes. Further we will study, when we will study about the p-prop element, then we will further study in a detail about the halogen. I think this much is enough for you for this chapter. Okay, now we'll come to the alkenes and arenes. Now we'll talk about the alkanes and arenes. Now what are, students, alkanes and arenes? Alkanes and arenes are hydrocarbon chain. Means alkanes and alkenes are hydrocarbon chain. Now hydrocarbon, what do you understand? First of all, understand hydrocarbon means hydrocarbon, you think this is hydro means hydrogen and carbon means carbon. Means those organic compounds which are made from the hydrogen and oxygen are called the hydrocarbons. Means hydrocarbon are those organic compounds which contains hydrogen or carbon, or we can say which are made from the hydrogen and carbon are called the hydrocarbon. So from this we have understood that alkenes and arenes are made up of hydrogen and carbon. Now what do you understand by the chain? Chain means in alkane case, the chain means a straight chain. In alkane case, if I will talk about, it means a straight chain. Now, straight chain of which? Because we are talking about they are hydrocarbons. It means the chain is of carbon and hydrogen. So it means when we link one carbon with the another carbon in a sequence in a straight chain, then it is called the straight chain. Because you know we have the branch chain also. So we are not talking about, in alkane case we will talk about the straight chain. Because alkane come in the saturated hydrocarbons which contain a single bond. When the carbon is attached with a single bond with another carbon, it is interlinked like a chain and it is making a straight chain, then it is called the alkane. It will come in the category of alkene. Okay, we'll study. I will give you the idea of the hydrocarbon. Don't worry, but I just give you the some idea. Now in a arenes, now I have talked about the arenes. In case of arene, the chain will be aromatic. The chain will be aromatic. Now, what do you understand by the student? Aromatic. Now, what is aromatic? Here I am talking about aromatic. Aromatic means it contains the cyclic group. As the simple example of the toluene and benzene is a very simple example of the aromatic compound. Means in aromatic there is a cyclic ring. In aromatic there is a cyclic ring or cyclohexane. Cyclic ring. Here see in each point there are carbon is present. Here is carbon is present. Means we are having 1, 2, 3, 4, 5, 6. We are having 6 carbon. We are having 6 carbon and each carbon is attached with a double bond. Means here alternate double bond. Understand? In aromatic ring there is a cyclic compound is there, and in cyclic compound there is an alternate double bond is present. Look at that. If I put a double bond here, then I will leave this single bond. Then I will put a double bond here. Then I will leave this. Then I will put a single bond, double bond here. So there are alternative double bond is present. And here the valency here I have 1, 2. So 2 valency is remain. This carbon, look at that. This carbon is attached with this carbon with how many bonds it is making? 1, 2, and 3. It means 1 valency is left. So it will be complete with H. Like this in every carbon. In every carbon complete 1 valency with hydrogen. Okay. So this is called a simple example of aromatic. And in aromatic another thing, each carbon and hydrogen means each carbon and hydrogen show the sp2 hybridization. Now, what do you understand by sp2 hybridization, student? Means all the carbon or the single bond or carbon, there is a carbon-carbon double bond is there. Their hybridization is sp2 hybridization. Now, how can you find out the hybridization? It's very simple. You will see how many bond the carbon is making. For example, here look at that. This carbon, I am taking this carbon. Similarly, it will be applied in other carbon also. Here in this carbon is making how many bonds? See, 1 bond it is making with hydrogen, 1 bond it is making with carbon, and 1 bond it is making with this carbon. So it is making how many bond? Total 3 bond it is. Total how many bond pair it is there? 3 bond pair it is there. So you know how can you find out the hybridization? Bond pair plus lone pair. So here the carbon is completing its all the bond, means all the valency means completing here how many bond? 3, and there is no lone pair because in carbon it is completely attached with it. 1 hydrogen, 2 bond, this is 3. Total 4 bond completed by of the carbon. So its valency is 3. So its valency is 3, then it will come in the category of sp2 hybridization, means 2 and 3. Understood this? So this is a small idea I have given you. Now, what again I am telling you, listen very carefully. Halo means halogen. Halogens are the element which belong to the group 17 of the periodic table. We will represent the element with the letter X. Their electronic outermost shell contains the 7 electrons. They need 1 electron to complete its orbit just to attain the noble gas configuration. Because every element wants to achieve the noble gas configuration so that it becomes stable. Don't want to react. That is why, because its valency is incomplete, that is why it will take part in the reaction. And one thing, students, they are all non-metals. These are all non-metals. You know very well about the bromine. Bromine is a non-metal which is found in the liquid state at room temperature. These are the gases. So you have understood that these are the electron. And one thing, you know that halogens families are having a very good electronegativity. Electronegativity, and you know fluorine is having a very good electronegativity. Now I use the term electronegativity. Let me tell you about what is electronegativity. Electronegativity means they have the good capacity to attain the electron. Means to electronegativity is the capacity to attain the electron towards it. अपनी तरफ खींचने की क्षमता होती है इनके अंदर, पोटेंशियल होती है कि इनके अंदर बहुत अच्छी है. फ्लोरीन need 1 electron, so easily it participate and it has the capacity to attain the electron towards it. Now this is a small idea I have given you. Now we'll come to the Okay, now we have understood that what are what is alkane, we have understood. Now we will come to what we have to talk about in this chapter about haloalkanes and haloarenes. Now what are haloalkane? When the halogen derivative of hydrocarbon chain, when the halogen derivative of I am writing in a short hydrocarbon chain, when the halogen derivative of hydrocarbons are when the halogen derivative of hydrocarbons are called haloalkanes. The halogen derivative of hydrocarbons are called haloalkanes. Means here the halo group is there, means halogen is there. Alkanes मतलब alkane मतलब hydrocarbon is there. ठीक है, तो यहाँ पे आप कह सकते हो कि the halogen derivative of hydrocarbons are called haloalkanes. For example, I am giving the example, you will understood very carefully. I am taking a very simple hydrocarbon of alkane. Means I am taking the element from the alkane family. That is, for example, I have taken CH4. CH4 is the first member of the alkane family. That is methane. Okay. Okay. In halogen derivative of hydrocarbon is formed when we replace one hydrogen from alkene or arene with their halogen. With the halogen, you will substitute the one hydrogen with any halogen element, then halogen atom, then it will be formed the halogen derivative. For example, I have taken a simple example, that is methane. Methane comes in the category of alkane. It is a alkane. It is a simple alkane. I will tell you, if you don't know what are alkane and alkane, I will tell you. Then alkane, this is simple example alkane. This is come in the category of methane. When I will replace, for example, if I have taken one chlorine atom, okay, I will replace one hydrogen with this chlorine atom, okay, by some any source. Then what will happen? It will form CH3Cl. Look at that. Now it's become halogen derivative. Now this is called halogen derivative. Halogen derivative of alkane, halogen derivative of hydrocarbon, and what we will call it? Haloalkane. We will call it haloalkane because here see, this is halogen. You have put it a halogen, and this is the alkane chain. Means this is the alkane family chain, so it's become haloalkane. Its name become haloalkane. What we have done? It's a simple. If you have to make a halogen derivative, you replace the one hydrogen with the halogen, then you will get a halogen derivative. Similarly, we can be do in the arene case also. If I have taken a simple example, I have taken the benzene. Okay, I have taken the benzene ring. Okay. Here I told you just now that in each carbon there is hydrogen. One hydrogen is present. So if I will replace one hydrogen, here it's carbon and one hydrogen is present here. If I will replace one hydrogen present here with a chlorine, okay, then if I will replace one hydrogen with chlorine, then what will form? Then if I will replace one hydrogen present here with chlorine, now it's become, what happened? Now it's become haloarene. Now halogen is present and this is a arene group, means aromatic ring. Now name of it is haloarene. So like this, what I told you. Now how you can be made the halogen derivative of hydrocarbon? When you will replace one hydrogen from alkanes with halogen or with halogen atom, then it will form the halogen derivative of alkene. Means that the name which we give it is haloalkane. If you will replace from aromatic ring, from any aromatic compound, one hydrogen atom from its group, from the ring, and you will put a halogen atom, then it will form the aromatic compound, then it will form the haloarene compound. So this is, I think you have understood, student, how to make the halogen derivative of hydrocarbon, from where it is come. So we'll now I told you about the hydrocarbon. Maybe some of the students have the confusion what are hydrocarbon. So let me tell you about hydrocarbon. What are hydrocarbon? It's a basic thing of we are revising. Let me tell you what are hydrocarbon. I think you have understood how to make a haloalkene. Halo means halogen, alkenes means a single chain carbon when they are attached with a straight chain, and you will replace one hydrogen with halogen atom, then it will form haloalkene. And when you will replace one hydrogen from the aromatic ring, then it will form the haloarenes. Okay. Now we'll come to the topic about hydrocarbon. Now I told you that hydrocarbon are the organic compound which are made up of hydrogen and carbon. Now hydrocarbon we will divide it into the student in two categories. Now first category, that is aliphatic. First category is aliphatic hydrocarbon. Now second category is, student, that is aromatic hydrocarbon. First of all, understood that hydrocarbon will divide into the two categories, that is aliphatic hydrocarbon and aromatic hydrocarbon. Now aliphatic hydrocarbon is further divided into the two categories, that is saturated hydrocarbons, and unsaturated hydrocarbon. Again I am telling you, student, hydrocarbons you will divide in the two categories, aliphatic hydrocarbons and aromatic hydrocarbons. Now in aliphatic hydrocarbons we have one category of saturated hydrocarbon and one category of unsaturated hydrocarbons. Now in saturated hydrocarbon, the compound which contain the carbon-carbon single bond, means the compound which are attached with the carbon-carbon single bond are come in the category of saturated hydrocarbon. For example, if a carbon-carbon single bond is present, then they will come in the category of saturated hydrocarbons. Now, for example, saturated hydrocarbon which contain a carbon-carbon single bond, we will call them alkenes. They are called alkenes. When carbon-carbon single bond is present, then they are called alkanes. We will give the name alkenes. Okay. So here you have understood why we have used the alkane. I told you that alkanes are those those hydrocarbons which contain a carbon-carbon single bond. So by this we have understood that carbon-carbon single bond elements are come in the saturated aliphatic hydrocarbon. Now carbon-carbon single bond is present. Now I am taking a very simple, the general formula to represent the alkane is, that is CN H2N plus 2. This is the general formula to represent the alkane. Now what is N, student? And I am writing here, just look at it. I will discuss this unsaturated afterward. Now N is equal to, it is here. Now N is equal to, it can be 1, 2, 3, 4, so on. Like this means this N is the number of carbon. It should be present. You have to put the value of N. Then you can make the members of the alkane family. For example, if I have taken the value N, I will put the value 1. Okay. Then 2 is given. Then N value 1 I will put as I have taken. Then plus 2. Then what you will do? 2 plus 2 was of 2 plus 2, it means 4. It's become 4. There is no need to write 1. It is defaultly mentioned that it is 4. So it means you have understood that methane is formed. So it's a general formula is similar like this. Like this you can make a C2H6, C3H8, C4H10. So like this you can increase the member chain of this by putting the value of N. So this is understood. Now methane, I have taken the example of methane. I told you haloalkane. Now what I have told you, students, now we have taken the member like CH4. Now I am telling you here only. I have taken the simple example of C4. I told you that if I will add one chlorine replacing the one hydrogen from this group, then it will form a CH3Cl, that is called haloalkane. So I think, student, you have understood how to from where this haloalkane words came. This is the this you have to know from where this word came. I told you from where haloalkanes came. Now you have understood that haloalkanes are the saturated aliphatic hydrocarbons. This, I think you have understood. One thing that I want to tell you, N value should never be start from 0. It will be start from 1, 2, 3 and 4. Because there must be one carbon at least. If you will put the value 0, how can it be possible? You can be increased the chain. So at least the value will start from 1. I think this is you have understood alkanes and alkenes. Now I think you have understood from where this haloalkanes came. Haloalkanes are the saturated aliphatic hydrocarbon. Now don't be confused. Now I will tell about the unsaturated hydrocarbons. Now let me tell you, I will write down the general formula CnH2n plus 2. Simple example I am writing here. Now student, we'll talk about the unsaturated hydrocarbon. In unsaturated hydrocarbon, the compound which contain the carbon-carbon double bond or carbon-carbon carbon triple bond come in the category of unsaturated hydrocarbon. Now in unsaturated means if carbon-carbon double bond is present or carbon-carbon triple bond is present, then it will come in the category of unsaturated hydrocarbons. Now if the carbon-carbon double bond is present, then you will call it alkenes, and when the carbon-carbon triple bond is present, then you will call it alkynes. Okay student, the general formula of carbon-carbon double bond is CnH2n, and that carbon-carbon triple bond, the general formula is CnH2n minus 2. So this is the general formula. The example of this, it will call it, a simple example of alkene is ethene. You can be say ethene is a simple example of carbon-carbon double bond, and carbon-carbon triple bond, a simple example, you will say ethene. You will not start with as we have started in saturated hydrocarbon, we have started from carbon 1. We will not start from the carbon 1 from the unsaturated hydrocarbon. We will start from the carbon number 2. Okay, because its first member is ethene, because we want a hydrogen 2. Now you have understood this unsaturated hydrocarbon, saturated hydrocarbon. Now we will move to the category of aromatic hydrocarbon. Now in aromatic hydrocarbon, as we have a simple example of aromatic hydrocarbon is, I have taken the benzene ring. This is benzene ring is present there, which contain the alternative double bond. This is a simple example of aromatic hydrocarbon. And aromatic hydrocarbon, one thing we know, according to the Huckel's rule. According to the Huckel's rule, it should be followed the Huckel's rules also. It will form the Huckel's rules also. What is Huckel's rule? That 4n plus 2. It means n, what is n? N can be 0, 1, 2, 3, etc. This is the n is a means 4n plus 2 pi electrons should be present there. Means there should be a, this is called pi electron. This is called single bond, sigma bond. This is called pi electron. See here one. This pi electron should be present there. So the formula is for the Huckel. It should follow the Huckel's rules also. 4n plus 2. If it is following the 4n plus 2 rule also, according to that pi electrons are present, then it will come in the aromatic category. Now see that if n is equal to 2, if we will put the value n 0, if we will put the value 0 plus 2, then what is become 2. How many electrons are present here? 2 electrons are present. Okay. And if 4 value, if we will put here value 1, if we put a value of 4, 5, 6, how many electrons? 6 electrons are present. So this is aromatic ring contain the 6 electron. It comes in the category of aromatic. It is following the Huckel's rules also. Mean in Huckel's rule, if it having 2 electron, 4, 6 electron like this, it will put the value of n. Then we come to know that it's come the category of aromatic ring. Now here it's 6 electron. See, it's 6 electron. 1, 2, 3, 4, 5, 6. It means this benzene contains the 6 pi electron. So it is following the Huckel's rules also. According to Huckel's rules also, we can say that benzene is a aromatic compound. So here we have understood how to do it. One thing here I have told you that n value is 1, 2, 3 or 4. Okay, 1, 3 and 4. But here I have put the value n 0, 1, 2, 3. So understand the difference why I have written it like this, because here n represent the number of carbon atom, but here n represent the pi electron, number of pi electron. So both are the different. Don't mix it. It representing the number of carbon atom, but here the n representing 0, 1, 2, 3. It representing the pi electron. Now, as I have talked about, now come to our point. We are talking about the halogens. Now, if I have taken the simple benzene ring, if I will take simple benzene ring and I will replace one hydrogen, because these all are sp2 hybridized. I told you before that all in benzene ring all the carbon atom are sp2 hybridization. If I will replace one hydrogen from chlorine, then what it will form? It will form a, now look at that, I have replaced one hydrogen with a chlorine atom, then it will form a halogens. Okay, now it form a halogen. So I think you have understood it from where halogen. Halogens is the hydrocarbons we in aromatic. In aromatic category the halogens come. I think this thing is clear in your mind, student. We have talked about the general thing, that is about the hydrocarbon. We have talked about the general basic thing. We have started the introduction. Then what are halo? What does you mean the alkanes? What means arenes? From where this haloalkane and haloarenes words are derived. Okay, they are come from the hydrocarbon, aliphatic, saturated hydrocarbons. It come the word haloalkane, and from hydrocarbon aromatic rings, aromatic compound, the haloarenes come. In this category, aliphatic hydrocarbon, we have to read about saturated hydrocarbon in this chapter. We don't have to go through the unsaturated hydrocarbon. So our focus is on the saturated hydrocarbon. So student, in the next video, today we have discussed about the haloalkane and haloarene. A basic idea we have understood about the chapter. Now in the next video, next chapter, what we will do, we will understand the classify, how we will classify the haloalkane and haloarene on the basis of the halogens group. On the classification we have to be studying. So thank you, students.